Hello, everyone. I'm Cecelia Martinez. Everyone can hear me okay, assuming? Perfect. Awesome. So yeah, I am the last talk before lunch. So once again, mobile deployments are getting in the way of what we really want to be doing. So my talk today is on shipping React Native apps. And so hopefully I can help make that process for you a little bit better by the time that we're done here today. So I am Cecelia Martinez. Yes, it's working. Okay, I'm a developer advocate for AppFlow. It's the mobile CI/CD platform built by Ionic. You can find me on Twitter and GitHub at Cecelia Creates, or feel free to also connect with me on LinkedIn. I got lucky, I got Cecelia Martinez as my URL. And I will be sharing these slides as well on those channels, as well as in the Slack channel for this event. So a little bit more about me and my background. I have a web development background. I also used to work at companies like Cypress and Replay. So I love working with open source developer tools and just helping make the developer experience better. Coming from web, though, into mobile deployments has been quite a journey. And so just to get a sense of everyone here today, raise your hand if you've deployed your app to an app store. So if you've been personally responsible for that process. Okay, so a lot of builders and shippers. Now raise your hand if you got it right on the first try. Nice, I don't believe you, no. So it's not easy, especially if, like me, you're coming from a web background, right? Web and mobile are very different. And so what is it that makes mobile deployments so different and much more difficult than web deployments? Well, ultimately, when you think about web, like you are in control. You set the rules. You decide what build stack you're going to use, what tools you're going to use, how you're going to deploy, when you're going to deploy. You are in charge of all of that, for better or for worse, right? For mobile, the platform sets the rules. So if you're developing for iOS, for Android, probably both, you are going to be beholden to specific standards, security requirements, SDK requirements, and processes in order to actually build for those platforms. With web, you're also building for another piece of software. You're building for a browser. Your application is going to be running against that, inside of that browser and running dynamically. For mobile, you're building for hardware. You're building an actual native binary, an executable, that's going to run on a device and interact with that hardware, which makes the build process more complex. With web, you also control distribution. You decide when you deploy new changes, you decide when to roll back. With mobile, you have to go through the app stores. App stores control your distribution of your apps. So yes, there's like some sketchy things you can do where maybe you send like an APK to someone and they have to bypass all the security features to install it on their phone. But most people aren't going to do that, so you have to go through the app store process to make that happen. So when we talk about shipping React Native apps, we're talking about going from code all the way to the app in your user's hands via the app store. And this is what that process looks like. You start with configuration, which is essentially preparing your app code for distribution. Then you're going to compile the signed native binary. Then you upload that binary to the app stores. Once it's in the app stores, then you distribute those to testers via test channels. And then finally, once your app has been fully tested and you're ready to release it, you publish it to all users. And you also need to maintain ongoing support of that version of the native application. So I'm going to be talking through these steps today, but I also want to talk about how we can do these things automatically, because there's a lot of benefits to automating parts of your deployment process. You have reduced knowledge silos. So the first company that I worked at, we had an iOS and an Android app. Whenever it was released, one person on the team knew how it was done. He would spend a weekend going through like a 37 checkpoint process of cutting that release and shipping it out. He's the only person who knew how to do that. So it creates bottlenecks and it creates knowledge silos. If you have automation, more people have visibility into what that process looks like across your team. It also allows you to have shared credentials and environment management. You don't have one machine that stores everything. You're able to use ephemeral environments for your builds and share so that anybody can kick one off and be in charge of that process. You also have improved release velocity. The faster that you're able to get your app into the hands of testers and identify where problems may occur, the better your overall deployment process becomes. And you also get visibility. Sometimes when you deploy a release, you don't even necessarily know like maybe which version is with your testers at any given point in time. You don't know which commit that version is tied to or what build it was associated with. If you have automations, you can see every single step in that process, have logs for every single step, so that you can debug when something goes wrong. So As we go through, I'm going to give some examples of how you can start to incorporate automation into your pipeline, into your deployment process, I'm sorry. You don't have to go straight from 0 to 60, like have a fully automated pipeline on day one, but you can start to incorporate some of these concepts into your deployment process. So we will start with configuration. And again, configuration is preparing your app code for distribution. This is going to be things like setting up your app assets, like your icons and your splash screens, setting your versions and IDs, and also flagging any variables related to optimization and security for production builds. When I talk about versions and IDs, so for Android, we have the application ID, we have the version code and the version name, and we also have the SDK versions. By that, I mean these are the minimum, target, and maximum versions of Android SDK that are compatible with that native version of your app. On the iOS side, you have a build string and then also a version number. Some of these you set them once and then you don't have to update them. Others do need to be updated for every single build. So you can do these things automatically. So some examples we're going to look at is how you can auto-update your configuration values and also how you can generate screenshots automatically from your UI tests. So the first is automating your configuration variables. So this is a tool called Trapeze. It is a mobile configuration toolkit for cross-platform and for native applications. This allows you to define a YAML file, which is then leveraged during a configuration step during your automation process. So here's an example of a YAML file, which is targeting the iOS platform. It's dynamically updating the bundle ID using a variable. You could also, for example, update your version code using the CI build number environment variable from your CI/CD provider. And we are also updating a build setting and then replacing an entry in our plist file. To correspond with this YAML file, we have a script in our package.json CI configure, which runs Trapeze referencing that CI file. So you could have different CI files for prod builds, for test builds, for different versions of your application. And we're passing through the CI platform so we know if we're building for Android or building for iOS. We can run this locally if we wanted to, or we can also have it run automatically as part of our pipeline. I talked about generating screenshots. Hat tip to Ranjak Ram for this. He did a talk at Deep Dish Swift where he talked about how you can do this with Fastlane Snapshot. It's driven with Apple UI and essentially takes snapshots of your UI tests in order to generate them for the app stores. So you can do that dynamically when you're already taking your tests. So there's some talks on how to get started with that. All right, so once your app is configured, it's time to start building. And again, by building, I'm talking about compiling the signed native binary. When it comes to building steps, you're going to need to think about the build stack first. And by build stack, I mean the infrastructure and dependencies that you need for your build. For iOS, you will need Mac hardware. So you'll also need to think about the build type. You have to specify a specific build type when it comes to running your build. For Android, you have debug and release. And for iOS, there's a lot of different types of builds, but typically you're probably working with development or app store build types. Then there's the code signing process. And the code signing process is really what makes this so complex because of the signing credentials that are needed for this. It's required for Android releases and all iOS builds except for Simulator. So anything that runs on an actual device for iOS, you do have to sign it. What this does is it validates the identity of the builder and that the binary has not been altered. And again, this is a requirement from the platform because the platform sets the rules, right? A quick note on build stacks. This is the example of our AppFlow build stack for macOS, our latest version. So these are what I mean when I say the dependencies that are needed to be installed in the environment. So we have certain versions of Xcode, CocoaPods, macOS. We also have NPM Node and things that are needed in order to build web builds as well. So if you are doing this yourself, you need to think about what you need to install in your environment to allow for that build to run. All right, so code signing. On the Android side, the credential that you will need is called an upload key. And this is stored inside of a key store. And so on the iOS side, you need two credentials, a signing certificate and then a provisioning profile. The signing certificate validates the identity of the signer and that they're authorized to generate that build, whereas the provisioning profile is a collection of the signing certificates that are available to be used, as well as what devices the application can run on. So for Android, you generate an upload key during the process of generating a signed bundle or APK in Android Studio. This is the easiest way to do it. You can also use Key Tool or to generate a key as well. But I like to work just in an Android Studio. So you'll select Generate Signed Builder APK. When you get to this step, under Key Store Path, you'll create New. And this is where you'll enter the information to generate your key. It's going to ask you for your certificate information, and you will also set both a key store password and a key password. And it's important to note these values because once you upload a signed bundle to the Google Play Store using a specific upload key, depending on your settings, you may not be able to regenerate it. It's for the life of the app. For iOS, there is an automatic signing section in Xcode. How many of you use automatic signing when you're building your iOS apps? Okay, cool, yeah. So automatic signing will manage all your signing certificates, provisioning profiles, everything for you within Xcode, as long as you have your Apple Developer Program profile connected. But I'm going to dig in a little bit into how you also can manually generate these credentials, just so you understand how it works under the hood. So for iOS, the signing certificate can be generated in Xcode. It can also be generated in Apple Developer Program, but it's a much more complex process that involves creating a certificate request file and everything. So I would recommend doing it right in Xcode. You can create a distribution or development certificate, depending on what type of build that you're doing. Provisioning profiles are generated in Apple Developer Program. You'll create a profile. You'll select a type as well. You can do development or you can do distribution. You'll also select the app ID that corresponds to that application, any certificates that are corresponding to it, any devices that correspond to it, and you'll generate that. So again, you can do all of this within Xcode. You can do all of the Android within Android Studio. But it's important to understand what's happening under the hood when it comes time to automate. So if you would like to automate this build process, the steps that are going to be involved is setting a trigger to trigger what's causing that native build. It could be on demand. It could be as a result of a PR or a commit. You'll need to install that build stack dependencies in the environment. Then you need to decode and apply the signing credentials in the environment. So those signing credentials need to be in the same environment where the build is taking place. If you're in CI/CD, that's the ephemeral environment that you're working with. And then finally, you also need to upload that bundle artifact to be able to access it so you can distribute it to your testers. So we'll run through an example of what that could look like. This is a GitHub Actions Android debug build. So we're running on an Ubuntu machine. The trigger is a workflow dispatch. So I trigger this manually whenever I want to do a debug build of a specific commit. And then it's checking out the code. This next section is where we talk about the build dependencies. So GitHub Actions runners do have a lot of pre-installed tools, including the Android SDK. But we do need to set up which version we want to run. And I'm also setting to cache Gradle for optimized builds. We're also installing the dependencies that we need for our React Native app. Then we are bundling the application. So we do need to bundle the app for React Native for Android debug builds and CI/CD. And then we are using Gradle to actually assemble that debug build. And finally, we're using the upload artifact GitHub action in order to ensure that that APK gets out of our environment and to a place where we can access it. So that's the process for an Android debug build. Android debug builds do not require signing credentials. So that's kind of like the first level. Once you have to include signing credentials, things get much more complicated. For React Native apps, you do need to configure the app/build.gradle file. You will find a signing config section. By default, it includes like a debug signing config that just uses a couple of default values. But you will need to update the release version to ensure that if you are in a CI/CD environment, that you are grabbing the environment variables for your key password, your alias, your key store password, which also needs to be uploaded in your CI/CD provider. The key store is the tricky part. So that's a file. That's not a value, right? So in order to ensure that that has been decoded, you have to actually encode it as a base 64, store that as an environment variable, and then during your CI/CD process, you need to get that value decoded and then make sure it's in that file that you're going to be referencing your build.gradle settings. So that part can be a little complex. If we take a look at what it looks like on iOS, These are the GitHub Actions docs for installing your Apple certificate and provisioning profile. You know, it talks about how you're grabbing those values, you're decoding it, you're creating temporary placeholders for them, and then you're making sure that they're in the right place in order for Xcode build to be able to use it. So this is a lot. And so that's why we really recommend using signing credentials tooling so if you are going to be building in a CI/CD environment. Signing credentials tooling allows you to store signing credentials in a shared managed cloud environment so that they can be accessed for every single build and everybody on the team. So your CI/CD provider may provide some like pre-built actions or steps to incorporate into your workflow if we're leveraging your signing credentials. You can also use cloud credentials management tools like Fastlane Match or AppFlow. So for example, in AppFlow, you upload your Android and iOS signing credentials, and then they are used whenever you create a new build. Or you can also use them in a GitHub Actions workflow, for example, and you pass through the name, which they're then grabbed from the AppFlow servers. So this is an option if you don't want to have to manually encode and decode your credentials for every build. All right, so we have a signed build. We've worked through all the errors in Xcode, with provisioning profiles not matching up with the right certificate because you accidentally created 3 certificates instead of 1, and you can't remember which one that you need to use. But we got there, and now we're ready to upload and test our application. So again, this step is about delivering the compiled bundle to the app stores and then getting it in the hands of your testers. How many of you do automated QA for your mobile applications? Okay, that's what I expected. So how many of you do manual QA then? Every other hand, let's see it. Okay. So yeah, so being able to deploy to your manual testers is a very important part of this process. And a lot of people will have very kind of ad hoc processes for ways that they do this. You may use quick sharing in Google Play to upload the APK. You may be sending the files dynamically. They may be grabbing it themselves off of wherever it is that you do the build. But there are specific test tracks for Android and iOS that can make this process easier. There is some options for automated testing on real and virtual devices, but I won't go too much into that because ultimately what you will find is that you do need manual testing on real devices. But first you need to set up your App Store accounts. So for Google Play, you have the Google Play console. You'll create your app, and you'll go through a really long questionnaire where they ask you things that you're like, I don't even know if this is for children or not. I don't think so, but now I'm questioning everything I ever thought about. So you'll set your content rating, every single data access request that you may need, like am I asking for the location, the permissions. You'll go through the questionnaire for that to get it set up before you can deploy to internal testers. For Apple App Store, you will do this in App Store Connect. App Store Connect is different than Apple Developer Program. So it's like 2 sides of a coin. You need ADP to generate the signing credentials. You need App Store Connect to actually deploy, and they will need to be connected via your Apple ID as the connector in between. So you'll create your new app, and then once you do that, this will give you a dashboard where, same thing, you can update your screenshots, you can change your app information, and this is also where you'll be able to set up for test flight. So for Android test tracks, you have 3 options that are available within Google Play Console. You have internal testing, which allows you to deploy to up to 100 users that have been predetermined via email address. If you need more than that, there is alpha or closed testing, which allows you to have a wider audience. Internal testing is nice because you can deploy unconfigured applications. So that's good for your QA team, your internal stakeholders. Once you get to alpha or beta, you should be ready for that app to be deployed to more users. Beta, or what's also called open testing, your app is actually in the App Store. It's just marked as beta. So it needs to be ready for users and fully configured. How many of you are using any of these testing tracks for Google Play to distribute? Okay, so it sounds like a lot of you are doing this more manually. So we'll definitely talk about that and how you can get that set up. So for iOS, you have what are called ad hoc builds. These allow you to distribute to up to 100 devices per year. So it's device-based, not user-based. You do have to register those devices by UUID in the Apple Developer Program or by connecting them manually to Xcode, which is very fun. But if you can also go with test flight. So test flight allows you to distribute to a much wider audience based on either private link or email invite. Test flight's also nice because it has some built-in tools, like being able to submit screenshots, bug reports for your QA team to be able to provide that feedback. It'll also automatically update them whenever a new version is ready. So we talk about Android and Google Play. Internal testing, I think, is a really great solution for working with your QA teams, your internal stakeholders. Again, you can have up to 100 users that you can distribute your app to, and it doesn't have to be fully configured yet. So it's great for those kind of early stage testing. Once you have your app completed and you go through that entire questionnaire, you'll be able to deploy for internal testing. You'll set up an internal testing track, and you'll add a list of testers. For me, it's just me, Cecelia, that's me. So I just have one tester. But once you have added the testers, then you'll be able to actually create a release. The first time that you create a release from Google Play, you have to upload it manually in Google Play Console. Every time after that, you can upload it dynamically via API or whatever automatic method you want to. But the first time, you will literally drag and drop your app bundle. It'll automatically pull the version, the API levels, the SDKs and everything from the bundle itself. And then you'll be able to release that to your testers. So for the Apple App Store, you have Test Flight. In that same dashboard, you'll just tab over to Test Flight, and you'll create a new internal group. This allows you to deploy to your testers using the Test Flight app. You can also enable automatic distribution. That means that every time new version that you upload will automatically be available to all your testers. Once you've done that, you can start uploading your builds. You actually can't upload your build in App Store Connect. You have to use an upload tool. So that can be Xcode, and there's a couple of other APIs, or you can use a build tool like AppFlow. So if you do want to automate this process, you have essentially 3 options. Like I said, you have App Store developer APIs that you can integrate with to send that signed bundle. There's also CI/CD integration tools. I mentioned Fastlane earlier for automating your screenshots. You can also use Fastlane to do this. And there's also full-service mobile CI/CD platforms that allow you to upload that process automatically. So we take a look at Fastlane. The way that Fastlane works is you actually define a fast file using pre-built or custom actions that do different steps, including building the app and uploading into Test Flight. It does require some configuration, but then during your CI/CD pipeline, it will reference the fast file in order to execute specific steps. If you do decide to go with the mobile CI/CD platform, you can typically have a workflow creator where you're building out an automation, where you choose the platform, and then you choose a destination of Test Flight, which means that every time that you trigger a new push to that main branch, that Git branch of main, your new version will be available for you in Test Flight, and your testers will get an email that that new version is ready. All right, so your app has been tested. It has 0 bugs. It's perfect. It's beautiful. It's going to get a 5-star ratings. You're going to boost right up in the charts, right? So you're ready to publish. And then once it's out in the world, and you've actually gone through that App Store approval process, you're going to have to support that app. That app version could live forever. When we think about web deployments, as soon as we push a new version, barring any like feature flags, caching issues, whatever, A/B testing, everyone has the same version. Like nobody can be on the old version of the app anymore. That is not the case with mobile. I don't think my Aunt Judy knows how to update an app. Like I don't think she's ever done it before. I'm pretty sure she just, unless it forces her to do it, she's never going to update it. So you have to think about supporting all the app versions of your app that live out there. That is if you can get approved first. How many of y'all have been rejected from the App Store? Nice. Already once today. Yeah. So it's a rite of passage, right? And these are the most common reasons provided by Apple why apps get rejected. But as we know, there's a lot more. There's a lot of reasons why you could get rejected from Apple or from Google. And the process can be hazy, right? Even the guidelines that they give us, like Apple says that the review process could take up to a week or more. Very exact, super scientific. So it's really hard for us to plan around this. And so it's important to understand like why apps get rejected and try and reduce those factors as much as possible. And the thing that will help with that is going through the process as much as you can, right? Getting a sense of what that experience looks like and developing a really strong checklist. I've seen some checklists that are like 70-point checklists, but the apps don't get rejected. So it can be really important to understand those clarifications there. I also mentioned support. I mentioned that you will have to support that long tail of app versions that exist out there. If you make a change to your API, if you make a change to something that you interact with your app, will older versions still work with that change? You also need to keep up with native dependencies and device-specific requirements. So Android and iOS will say, we need you all to update to this new version of the SDK within the next 6 months because there's a security concern. You need to be able to maintain and stay up to date with those because if you don't, you can get delisted from the app stores. There is an option to have forced upgrades. Like you may see this a lot with like banking apps or anything that is related to security issues where you try to open an app and it says you have to use a new version. You can do that if you need to. Sometimes it prohibits people from just like, they just give up on your app. Like one time I had to do that for my Dunkin' Donuts app and I was like, I just want my coffee. Please do not make me upgrade to the newest version. I haven't had caffeine yet. But that can be an option, but you need to think about the user experience there. All right, so I want to talk about tooling. So we covered a couple of different tools and examples that you can use to automate your deployment process. And I want to make a quick note here because in talking to some people here and like at other events I've been to, sometimes developers, especially building native applications, have this idea that, you know, if we care about the user, we have to do it this way. If we care about the user, we have to do it the hard way, essentially. And in my mind, if we care about the user, we need to be spending as much time as possible working on things that are user-facing, working on things that make that user experience better. So leverage tooling and automation wherever you can so that you can spend more time working on what you need to be working on. So some of the tooling options that you have, these are kind of big picture. You can leverage your existing CI/CD platform. This is what we saw in the GitHub Actions example, using either Actions or Fastlane or Trapeze. This is where you're going to integrate mobile-specific developer tooling as needed, you know, mix and match for either single functions or multi-function. You can also use a platform or framework-based solution. This is going to be essentially a full-service multi-function platform, but designed specifically for either iOS or Android, or for whatever framework that you're using to develop. So an example is a platform-based one is going to be Xcode Cloud. An example of a framework one is going to be like EAS. The other option that you have is an all-in-one mobile platform. This is multi-function and it supports whatever platform or framework that you're using, and it'll handle the entire deployment process. Some of the things that you need to think about as you're deciding what tools to use. The DevOps expertise on your team. If you have a dedicated DevOps team that will handle all your mobile deployments, the tools that you're going to use are going to be very different. If you have one person on your team, typically like a team lead, who's responsible for making sure the app gets out, they may not want to handle very complex DevOps-style configuration YAML tools. So you need to think about what that looks like on your team and who can own that process. You also need to consider any existing infrastructure do you have. Are you already provisioning Mac hardware? Do you already have existing CI/CD tooling that you can leverage and integrate with? Are you going to need to build from scratch? That can also influence what type of tool that you use. And finally, you need to think about what platforms that you support and what frameworks are used to build at your organization. So if you have I touched on some companies who have like 20, 30, 50, 100 apps that they're building, right? And some of them may be using different platforms, or built for different platforms. Some of them are using different frameworks, depending on what the build stack of the client requires. So based on that, you need to think about, does a single platform or framework tool make sense, or do I need something that supports everything? Again, you're going to want to choose the right tool for the job. But as long as you're using tooling that helps you to speed up your deployment process, the faster you can get feedback from your testers, and the faster you can get back to actually creating user-important functions. So if you have any questions, we do have an ebook, Solving Mobile CI/CD with AppFlow. You can also, again, connect with me at Cecelia Creates on Twitter. And feel free to also come and say hi to us. We'll be at the booth out in the lobby. But thank you so much.